Our project topic is performance analysis of harmonic loss using hybrid renewable energy system. Firstly, I am going to explain about connections given. The wind source system has the range of frequency about 50 Hz, which is connected to DC rectifier of range 50 volt. Then it is connected to bidirectional DC to DC converter, from which we calculated the input voltage and output voltage by varying frequencies. Similarly, the solar PV system is also connected to the bidirectional DC to DC converter, from which we calculated the input and output voltage and input and output current. Now these both are synchronized by the DC bus, which is then connected to the AC to DC converter at the back end. Altogether, it is connected to the stimulated transmission system, which is of 220 kilovolt three phase with RY, YB and BR. By calculating the distance from 0 km to 180 km, we noted the harmonics created by using harmonic tester without filter. In the second part, by using the MATLAB tool, we designed a hybrid renewable energy system without adding filter. Firstly, from the solar PV system, the input voltage is connected along with the resistance, which is then connected to 6 MOSFET. Each values are given respectively. Later, in the wind source system, it is connected to VI characteristics and it is connected along with the same MOSFET, which is connected to solar system. As a whole, both are connected with bidirectional converter circuit, then connected to the three-phase RL load through the transmission line. From the transmission line, it is connected to the VI characteristics of the circuit and it is connected along with the three-phase RL load. After that, the design is completed and it is ready to run. We run the system to get the output from each solar and wind and transmission system by the values given already to each circuit system. After running process, we get input voltages 100 volt. Then the input solar PV voltage is noted, followed by output load voltage and output current voltage. And then in the three-phase circuit transmission side, we get the transmission output voltage and output current. With this, we get all the input and output result from the harmonic loss without filter design. Then we move to the harmonic loss with filter design. As I told already, the solar PV is connected with input voltage and also connected across resistor branch. From the wind source, it is connected to 6 MOSFET, which is then connected in series with RLC circuit and connected parallel to the inductor circuit. In the same way, the wind system is connected to VI characteristic circuit and it is connected along with MOSFET. The same RLC circuit and inductor circuit. From the RLC branch, we calculate the voltage and current. Both wind and solar are connected to the bidirectional DC to DC converter. Then in the three-phase transmission system, it is connected with two RLC branch circuit in which resistance and inductor values are given. It is then connected with voltage and current, which is in series connected with a three-phase RL load. From the variation in harmonic loss are the noted and compared with without filter harmonic loss values. Then the running process takes place. The wind source input voltage and current is noted, which is followed by input PV voltage. Then the load current output and transmission output voltage are shown in the graph. Later, the transmission output current is noted. With all the given results, we compared and get the needed output. From this project, it is understood that the harmonic loss is reduced when we added filter across the transmission line. Thank you.